Let us solve another question which was given in GATE 2018 on the topic memory. Okay, let us see this question. The size of a physical address space of a processor is 2 power p bytes. The word length is 2 power w bytes. The capacity of the cache memory is 2 power n bytes. The size of each cache block is 2 power m words. For a k-way set associative cache memory, the length in number of bits of tag field is what? This is the question. And this is our very regular practice of dividing index, tag, and a word field or a block field. Of course, we are pretty much habituated to this. Solving this question is somewhat pretty much easier. Now let us segregate the details that are given here. The thing is, the first detail given is physical address space is equal to 2 power p. I will write it as physical address space is equal to 2 power p bytes. Right? Then the next thing is the word size is equal to 2 power w bytes. The word size is equal to 2 power w bytes. Word is equal to 2 power w bytes. Okay, and the cache size, the cache is equal to, where is cache? Cache is equal to 2 power n bytes. Cache is equal to 2 power n bytes. Now here we have got a block size. Okay, what is the block size? The block size is equal to 2 power m words. Okay, the block size is given in the number of words, but we need to convert it into number of bytes. So if we can do that, it will be equal to 2 power m into 2 power w. That is 2 power m plus w, because word is equal to 2 power w bytes. One word is equal to 2 power w bytes. One block is equal to 2 power m words. So that is, we need to multiply the number of words into number of bytes. So we will get the total number of bytes per a block. Okay, number of bytes per a block is equal to 2 power m plus w bytes. Okay, 2 power m plus w bytes. So let us go for a k-way set associative. Okay, in k-way set associative, you know how to divide. That is, in k-way set associative, in k-way set associative, you know how to divide. That is, this is the physical address. The physical address will have three parts. One is tag portion, and one more is the next one is set portion. It will give you the set number. The total number of bits will give you the total number of sets in a k-way set associative. And finally, we do have the word portion. This can also be called as a block offset. Okay, that is the block size. That is, number of lines in cache is equal to number of lines in cache is equal to number of lines. How are you going to say the number of lines? The total cache size divided by cache size divided by a number of the size of the block, right? The block size. If you divide cache size with the block size, you're going to get the total number of lines. So the cache size is equal to 2 power n, and the block size is equal to 2 power m plus w. So that will be equal to 2 power m minus n minus w. 2 power n minus m minus w, because the cache size is equal to 2 power n and the block size is equal to 2 power m plus w, right? So when we perform subtraction, it will be the number of lines in the cache will be equal to 2 power n minus m minus w. Okay, so the number of sets will be equal to obviously the number of lines divided by k. Rather, number of lines divided by the associativity, right? Number of total sets. How are we going to determine the number of sets? We need to find out the total number of lines divided by k. In the direct mapping, if it is equal to 1048, two-way set associative mapping, it will be equal to 512. In the direct mapping, if that is equal to 1024, total number of lines, rather total number of blocks are equal to 1024. In the set associative mapping, it will be equal to 1024 divided by 2, that is equal to 512. So in order to get the number of sets, we need to divide the total number of lines or blocks divided by k. That is a way associativity, right? So that is equal to 2 power n minus m minus w, 2 power n minus m minus w divided by k, right? So set number will be equal to, I'm writing here, okay? So set number will be equal to log 2 n minus m minus w, n minus m minus w by k, okay, which is equal to n minus m minus w minus log k, minus log k. That will be equal to p minus n plus log k. So p minus n plus log k, okay, this is the answer. P minus n plus log k is the correct answer. This is for tag, okay. If you want to get a tag, the total physical address minus n of log k, okay. So this is the correct answer. P minus n log 2k, B is the correct option.